Hello, welcome back to the channel. So let's continue our previous video and do one more question on solving indefinite integrals using trigonometric substitution in this case. So again, a basic overview about what we did in the previous video. Whenever you have a pattern in your indefinite integral which looks somewhat like a square plus minus b square x square, it will give you an idea that if you would use trigonometric substitution in order to solve for your indefinite integrals, you'll make your indefinite integral expressions or definite integral expressions as well much more simpler than your original integral expressions over here. So if you have not watched my previous video, I would highly suggest you to first watch my previous video in order to get the full context of what we would be doing in this video. So again, we see the same pattern over here, a square plus minus b square x square. If we take our b to be 1 and a to be 5 and take the negative sign in between, we can write this expression as 5 square minus x square, right, which is 25 minus x square. So we see a pattern over here which looks similar to a square plus minus b square x square. So that is why it gives us an idea to use the trigonometric substitution and one of these three trigonometric identities in order to simplify our definite integral over here. So let's try to solve this question and see what specific trigonometric function we can take for our x to be in order to simplify this square root expression over here. And we can clearly observe that since we know that sine square x plus cos square x equals 1, so if we move the sine square or the cos square to the other side, let's suppose we move the sine square to the other side, we know that cos square x equals 1 minus sine square x, right? And we can clearly convert this 25 minus x square expression into 25 times 1 minus sine square or 1 minus cos square expression, right? If we take our x to be 5 sine theta or 5 cos theta accordingly, right? So let's try solving this question by taking our x to be, in this case, 5 sine theta, and see how we can convert our definite integral expression over here and if it makes our expression simpler or not. So let's write the integral expression again. In this question, we have to calculate the integral from 0 to 5 by 2 dx upon under root 25 minus x square, right? So we will assume our x to be 5 sine theta in this case, and again we took our x to be 5 sine theta because we saw a pattern of 1 minus sine square x being cos square x, right? So that is why if we take our x to be 5 sine theta, we'll have to take the derivative of x with respect to theta as well because we are doing substitution. So this is 5 cos theta over here, right? If we take the derivative of this expression over here, it would be 5 times the derivative of sine theta, which is 5 cos theta over here, right? And let's shift the dx to the other side. It would be 5 cos theta d theta in this case. And again, one more thing, since we are using substitution in this case, we will have to convert our endpoints as well according to the new function, right? So the endpoints were based on the x values, right? And now since we are converting our dx to d theta, we'll have to change our endpoints as well. And in order to convert them, we'll use this function over here, right? We'll use this conversion over here. So when our x is equal to 0, our 0 is equal to 5 sine theta over here, right? In this case, right? So our 0 is equal to 5 sine theta, which means sine theta is equal to 0, which means theta is equal to 0, right? And similarly, when our x is 5 by 2, which is our upper endpoint, we can write 5 sine theta as 5 by 2. So this 5 will cancel out. Sine theta equals 1 by 2. So theta would be 30 degree over here, right? Or you can write this as simply pi by 6 over here, right? Because we know that sine of 30 degree is 1/2 over here, right? So now since we have all the conversions over here, so let's convert this definite integral by using all the conversions that we have. So this is the definite integral that we have. Our endpoints have changed. Since we are taking d theta, our endpoints have changed from 0 to pi by 6, right? Because when our x is equal to 0, our theta is equal to 0, x is 5 by 2, theta is equal to pi by 6, right? So that is why the endpoints changed to 0 to pi by 6 in this case. And 1 upon under root 25 minus x square is Since our x is 5 sine theta, so 25 minus x square would be 25 minus 25 sine square theta, and dx in this case is again 5 cos theta d theta over here. So 5 cos theta d theta in this case, right? So let's simplify this expression again, and we would get square root 25 1 minus sine square theta, and then 5 cos theta d theta in the numerator. So we know that 1 minus sine square theta is cos square theta. We can write this expression as simply 0 to pi by 6 1 upon under root 25 cos square theta, and then again 5 cos theta d theta in the numerator. So this root 25 cos square theta will simply be 5 cos theta, right? If we take the square root of the whole expression, it would be 1 by 5 cos theta, and we are multiplying it with 5 cos theta as well. So this 5 cos theta will cancel out with this 5 cos theta, and we will get our final integral to be 0 to pi by 6 of d theta in this case, right? And we know the integration of d theta, which is theta from endpoint 0 to pi by 6. So that is why in this case our answer would be simply pi by 6 minus 0, which is again pi by 6. So this would be your final answer to the definite integral of this expression over here. And again, you noticed how easy it was to solve this integral over here, this definite integral over here, rather than solving this complicated definite integral in this case, right? So that's it for this video. Again, the main takeaway from this video is whenever you have your integral expressions of the form a square plus minus b square x square, you have to assume your x function to be a trigonometric function and use one of these three trigonometric identities in order to solve or simplify your definite or indefinite integrals in those type of questions. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.